Okay, number 14, recursion. As they say, if you look up recursion in the dictionary, it just says see recursion. Good. So where do we start here? Well, line 24 is an error, according to the bottom right, so this fails because the is-even function is defined here and it's not correctly defined. How do we know if something is even? Well, if the something we're looking at is 0, then the answer is true. And if it's not 0, then it is not is-even of the decrement of it. This is because when you decrement a number, so let's take the number 5, that would not be even, but once you decrement it and get 4 out, that would be even, so you have to use a not there. And that now works, good. Let's move on, see what the next one is. Okay. False is even, big int, line 30. Too many stack frames. Okay, so there's no end recursion. Tail recursion, sorry, it's called tail recursion. There's a certain keyword for tail recursion, recur. This is a limitation of the JVM, isn't it? You have to trick it to do tail recursion. Okay. Def n is even, big int, loop n, so we've got an accumulator, we've got true, okay. Oh, hang on. Is n 0? No, how do you meant to read this loop? Okay, I think the way you're meant to read this is for the first time it starts, n is here something different from this n. The first time you started, this n is this n here, the second n, and the first n is now defined in this area. And ac is now defined in this area as the value true. But when you call recur, so the next time you go through this loop, this n is going to be 1 smaller, and ac is going to be not ac. So if n is 0, you just return ac. That seems to make sense. Good. If n is 0, you just return whatever is left in this accumulator, I suppose, ac. Let's move on. Line 33, where's that got to? Recursive reverse. Reverse interactions is easy when you have not gone far. Yes, it most certainly is. Collection. You reverse things by... Do we want a loop here? Do we want to use... Well, just use an accumulator and a loop here. Okay. So what we're doing is we're accumulating things in an empty list. It starts as an empty list, and if we need a call as well, then we need to take that first element, so we know where we are. If is there an empty function? Call, we just return the accumulator. Otherwise, we return a recur of rest of call, and this is going to be conj of ac and first of call. Got to shut lots of things, is that enough? Okay, that seems to have worked. Let's explain what I'm doing here. It is a standard trick for reversing a list. In this case it's easier because I'm using vectors. If I were using a list, I would have to keep a reference to the first element of the list and then constantly change this reference. So basically the list gets unwound. And while it's getting unwound, you build up a new list. In this case, you build up a new vector. By using the conj function, we found that conj adds an element to the end. And to begin with, ac is equal to 0 is an empty list, and conj adds things to the end of it. Interesting, why did it do that? Well, that would also work, wouldn't it? No, it doesn't. It must be an empty list. Conj ac first call. Strange. Good to think about that. Let's move on. Simple things may appear simple. Well, factorial is a very classical thing to do. So let's just write the standard factorial algorithm here. Is if equals n 1, for example, let's return n, otherwise you return factorial, n times n factorial of dec n. That's the standard factorial function, which works until things get very large. So here we're in trouble, it doesn't work. So I imagine to get that to work we're going to have to use a loop. So just define a loop. N is n and ac starts at 1. If n is 1 we return ac, otherwise we recur with dec n, and ac is going to be times ac n. Close. Okay, let's see if that works. So if I made a mistake. It hasn't changed. Yes, it has now changed. Okay, that worked. So the one question I have is, why does this require an empty list for the accumulator rather than a vector? Not sure, because I thought conj added things to the start of a list. And it adds things to the end of a vector. It may know that, no, I'm quite unsure as to why that works. I'm going to look that one up. Okay.